Good morning, dear colleagues. Theme of my report is development of an intelligent search engine using the GPT model for GrantsForScience platform. In the modern world, research and innovation projects play a key role in developing new technologies, improving the quality of life and solving global problems. At the same time, researchers often face significant difficulties in finding funding and partners to implement their project. On the other hand, companies and investors are looking for opportunities to collaborate with scientific institutions to develop innovations and implement new technologies. Grants serve as a primary source of funding for many scientific research projects. They cover expenses for equipment, materials, researcher salaries, and other costs associated with conducting research. Timely and efficient grants searching is critical for the successful execution of scientific projects. Securing grants ensures that researchers have the necessary resources to pursue innovative and impactful studies. Manual grant search involves browsing numerous website databases and other sources of information. This process is time-consuming and often ineffective, as researchers may miss important opportunities due to the sheer volume of information and limited time for processing it. Here, we described the main problems of scientists and investors. For scientists, there are difficulty in finding funding. Many researchers experience difficulties in finding and applying for grants relevant to their project due to the complex and disparate nature of existing grant database. A lack of networking opportunities. There is a lack of platforms that facilitate effective interaction and collaboration between scientists and potential industry partners of investors. A limited visibility of opportunities. Researchers may not be aware of all available funding opportunities, and grant application processes are often complex and time-consuming. For companies and investors, there are difficulty navigating and research landscape. Companies and investors find it difficult to identify and connect with relevant scientific institutions and projects that match their interests and goals. Risk of investing in unproven ideas. Reliable mechanisms are needed to assess the viability and potential impact of scientific projects before deciding to invest resources. The need for collaboration platforms. Companies are looking for more structured ways to collaborate with the academic community, including joint research initiatives, technology transfer, and innovation projects. Additionally, manual search methods lack the ability to comprehensively analyze and cross-reference data from multiple sources, leading to potential overthinking. Therefore, the authors came up with the idea of developing a platform, GrantsForScience. GrantsForScience.com using advanced artificial intelligence technology to simplify this process and increase their effectivity. There are currently many developments in the field of artificial intelligence. The most famous are, of course, the product of the OpenAI companies such as GPT. GPT is a natural language processing technology based on a transformer architecture that learns from a large amount of text data and is capable of generating high-quality text. These models are trained on huge data sets and learn to understand the syntax and semantics of the language, which in particular makes them powerful tools for building semantic networks and domain models. The ChatGPT model is built on top of the OpenAI GPT-3, GPT-3.5 and GPT-4 family of large language models. The fine-tuning of the chatbot was performed using both supervised learning methods and reinforcement learning. Other notable projects using GPT include, among others, GitHub Copilot, Copy.ai, Jasper.ai, Algolia, SearchGPT. Meta recently opened access to its new model Llama 3.1, which, according to many tests, surpassed such giants as GPT-4, Cloud 3.5 Sonnet, and Google Gemini. Authors will plan to research and compare this new model with the GPT model. Now let's the concept of architecture, implementation, and the technical facets of microservice designed for the intelligent search of scientific grant models. Intelligent search employs artificial intelligence and machine learning techniques to analyze large volume of data and find relevant information. In the context of scientific grants, intelligent search can automatically process information about researchers, their publications, and relevant scientific fields to identify the most suitable grants. This approach not only saves time but also enhances the accuracy of the search results by considering a wide range of parameters and data source. Intelligent grants search offers several key advantages. There are automation reduces the time and effort required for grant searching, allowing researchers to focus on their core activities. Intelligence utilizes AI to find the most relevant grants based on the analysis of scientific publications, thereby increasing the precision of search results. Result quality provides accurate and relevant search results by considering the specific research areas and interest of the scientist. Scalability. The system can be expanded to search a large number of sources, accommodating the growing needs of the research community. Continuous updates keep researchers informed about new funding opportunities as they become available, ensuring that they do not miss out on potential grants. Microservice architecture involves developing individual services that perform specific tasks and can interact with each other via API. This modular approach allows for easy scaling of the system, adding new features and maintaining high availability and fault tolerance. Microservices can be intermediately developed, deployed, and managed, which enhance the flexibility and resilience of the overall system. Here we can see architecture diagram of the intelligent search microservice. Grants searching is performed based on input data such as Scopus ID or seed, first name and last name of the researcher. These identifiers allow the system to gather comprehensive information about the researcher's publications and scientific contributions, which are critical for matching the researcher with relevant grants. The search result output data are provided in a JSON response with a parameterized list of found grants. Each grant entry includes the title, description, link, source name, and metadata. This structured format facilitates easy integration with other systems and applications that the researchers might be used. The architecture of the microservice includes the following components. There are API endpoints, database, stores information about users, their request and search results, ensuring data persistence and reliability, and grant search mechanisms comprises a parser and an analyzer and a searcher, each responsible for specific tasks in the grant search process. On this slide, we can see API specification more details. There are get status, health check of the service to ensure it's operational, post-grants search initiates the grants search task based on the provided input data. And get job result retrieves the result of the grant search task using a unique job identifier. On this slide, we can see search job concept and statuses. And now we can describe grant search mechanisms. It consists of parser, analyzer, and searcher. The parser searches for titles and abstracts of the scientist publication in various sources, such as Scopus. The result of the parser's work is a list of found publication titles. This step is crucial for gathering and the necessary data to analyze the researcher's area of expertise and interest. The analyzer determines the parameters of the publications found in the previous step. It classifies the publication into three lists: research subjects, scientific fields, and research directions. This classification is essential for accurately matching for researcher with relevant grants. The searcher conducts the grant search in open source, such as the European Union Funding and Tenders portal. It uses the parameters of the publications determined by the analyzer to find grants that align with the researcher's work. This component ensures that the search results are highly relevant and tailored to the researcher's need. The prototype of the intelligent search microservice for scientific grants consists of limited K components that work together to facilitate the search and retrieval of relevant grant opportunities. Here we can see the K elements of intelligent search microservice implemented within a prototype highlighted by green and yellow colors. The next slide and also I forgot it consists yeah, I can say that it consists of three API endpoints described above. The next parser using Scopus Search API, analyzer, and searcher using EU fundings and tenders portal. The analyzer uses GPT 3.5 Turbo to generate a JSON with search parameters based on the titles of scientific articles. GPT 3.5 Turbo was chosen for its optimal balance of cost and capabilities. Interaction with GPT occurs via HTTP API with a temperature setting of 0.5 determined experimentally. This setting ensures a balance between creativity and coherence in the generated responses. The model has been trained on a diverse range of internet text, which allows it to handle various tasks, including text summarization, translation, and content generation. The temperature parameter in GPT controls the randomness of the output. A lower temperature close to zero makes the model's output more deterministic and focused, while a higher temperature closer to 1 allows for more randoms and creativity. For the grant search analyzer, a temperature of 0.5 was chosen to maintain a balance between generating diverse responses and ensuring relevance to the input data. Analyzer utilizes GPT API in assistance mode, asking the following message. Fill in science branches, research areas, research subjects, JSON based on a list of scientific articles. Name given contains a list article names provided. GPT returns JSON filed by value. Part of the program code utilized to analyze article names using GPT. You can see on this slide. Prototype was tested using real researcher profile data. It's my profile. In an example provided within this article, we used our seed and Scopus ID of and after. For a given researcher, a prototype returned 90 relevant grants found on EU funding and tenders portal, 10 for each of 9 keywords found by analyzer on a basis of 12 articles found within Scopus. Job result response contain results of searcher list of grants that match keywords defined by analyzer for articles found by parser. Output of intermediate steps are included as well articles word. For example, here you can see job result response, and the microservice service is implemented as a Docker Compose application with the following containers. Python 3.10, Flask, Marshmallow, Request, API Engine, Service, Orchestration, Salary Redis, asynchronous execution of grant search tasks, Redis database for storing intermediate result, and task quest, Salary, Flower, task monitoring and debugging. Application is hosted at DigitalOcean and is IP restricted. Postman HTTP client is used to test API endpoints. The microservice is intended to be used as part of the infrastructure for a system that searches for grants from numerous open source on the internet. The system will allows organization and scientists to create account and reveal out profile, enable on-demand searches for grants based on the profiles. Companies, organizations will be able to post tasks and search for performers among registered users, scientists, and organizations. Send daily notification about new grants and in the sources, ensuring that researchers are always up to date with the latest opportunities. The system will feature a user-friendly interface where researchers can input their profile information and receive personalized grant recommendations. It will also provide a dashboard for monitoring search results and managing profiles. The microservice service can be integrated with other research management systems, allowing seamless data exchange and enhancing the overall efficiency of research administration. In conclusion, we can see that the principles, architecture, and technology for creating microservices for intelligent search using artificial intelligence technology such as GPT are proposed, which allows creating a scalable, reliable, and efficient search system GrantsForScience. We can select this advantage. There are high level of automation, aggregation of data from different sources using intelligent search, scalability. Intelligent search of scientific grants significantly improves the efficiency and accuracy of research funding search. This approach not only saves researchers time and effort, but also ensures that they do not miss valuable funding opportunities. The next steps to develop a comprehensive grant search system, namely expanding the functionality to cover more sources and provide more detailed search results, scaling the search, adding more parsers and search engine to process more data and improve the accuracy of the search, caching mechanisms, namely implementing caching to reduce the number of queries and speed up the search process. Unit testing and technical updates, continuously improving the system through testing and regular updates. We are open to cooperation, and we also invite partners to our project Grant for Science. Thank you very much. Thank you for attention. You're welcome.